Thermochemistry. Energy cannot be created or destroyed, only transferred. And that is the law of conservation of energy. And here's just some brief information, the basic information that we need to know for our unit of study on thermochemistry. First of all, energy is the ability to do work or produce heat. So say for example we have gasoline that we put in our cars to make our cars run. Well, that is a form of energy that we're using to run our car. Our internal combustion engine burns the gasoline, and that's converted into energy to move your wheels, but it's not 100% efficient, so it also gives off a lot of heat. And so that's why our cars have radiators on them, so that they can dissipate that heat and keep the engine from failing. Heat always flows from high to low. Okay, so heat always flows from a higher temperature to a lower temperature. So there's really no such thing as cold, it's just less heat. So if you think about it that way, then you can understand that it flows from a high place to a low place. And again, energy cannot be created or destroyed, only transferred. So energy is transferred from one object to another. So if we look at our two graphs here, we have two kinds of reactions, endothermic and exothermic. This first graph is the exothermic. The y-axis here is increasing energy, and the x-axis is the progress of the reaction. So on an exothermic reaction, we see that here the reaction starts with stored energy or potential energy, and it's at this point. Now as the reaction progresses, it goes through an activation energy period where we have to activate it, and then the reaction, as it happens, releases energy, but the energy it releases gets less and less and less until finally the reaction is finished and we have this much energy right here where the dotted line is, that much energy. So we see that on an exothermic reaction we started with this much energy, and by the end of the reaction we only had this much. So this arrow right here shows us that this is the amount of energy that the reaction lost or gave up. Exothermic means to give up or to exit, to expel heat. Thermo, exothermic. So this is how much energy, again, that the reaction gave up. Now the other side of that is an endothermic reaction. Here we see that the reaction starts with this much energy, and as the reaction progresses over time, it absorbs energy to finally rest at this much. So this line right here, this arrow, shows how much energy was absorbed by the reaction. So going back to an exothermic reaction, when it releases energy, remember, energy is the ability to do work or produce heat. When it releases energy, we detect this as getting hotter. So if we were able to touch the container that the reaction took place in, then we would actually feel warm. And there are some consumer uses of this exothermic reaction. For example, if you think about the heating pads, it's not used, it's called thermal heat, I believe, I'm not sure, but it's a little packet that you open up, and it has little hard discs in it, and it has an adhesive, and you can put that on your skin somewhere where you're having an ache or a pain, and it's actually a chemical reaction that's taking place with the air, with the oxygen that's in the air, and it's producing an exothermic reaction, and that heats up, and that is absorbed by our muscles to help sore muscles. Okay, and an endothermic reaction is going to feel cold in your hand. And there's also some ice packs that you can get. It has like, it's a little packet, it's like gel, and then there's another packet inside it that you actually have to break, and then you shake it up, And it's a reaction, a chemical reaction that's taking place in the packet, and the reaction is endothermic, so it gets very cold and we can use that as an ice pack. Okay, so those are two different types of reactions. So let's look at some problems that we're going to have with thermochemistry. Here's an example problem. How much heat, and this is also the problem that's on the guided notes that you glued in your notebooks on page 23. So how much heat would have to be absorbed by 2,000 grams of water to change its temperature from 20 degrees to 50 degrees Celsius? And we're going to use the value of 4.18 joules per grams degree Celsius for the specific heat of water. Well, when we are faced with this problem or any kind of problem, remember we're going to use the GSP method. The equation that's associated with thermochemistry is Q is equal to mc sub p delta T. Well, so what do those mean? Well, we use Q to mean heat, and heat, the unit that we use to measure heat in, is joules or kilojoules. So that's J or kJ. M is equal to mass, and we measure mass in grams. Cp, or just C, is the specific heat of the substance, and the unit for that is joules per grams degree Celsius. And last, the delta T, the triangle means delta, it means a change in temperature, and we measure temperature in Celsius. So when we have a problem like this, we have to look at the information that's given and make sure that it's in these units. If it's not in these units, then we have to convert it to those units. So say, for example, if you get a problem where it tells you the heat, but it tells you in kilojoules, then we need to convert that over to joules before we actually plug it into our problem. Okay, so let's look at solving this problem. And as I said before, we're going to use the GSP method. G, what's given, S, what are you solving for, and P, what is the plan? And the plan in this particular case is our formula, Q, is equal to mc delta T. So what do we need to do first? We need to circle in our problem the information that's given. So we're going to circle 2,000 grams. That's a given information. That's numbers. We'll circle 4.18 joules per grams degree Celsius, and we're going to circle 20 to 50 degrees Celsius. Now let's go ahead and label these. Oh, and I'm sorry, underline what you're looking for. How much heat. So in our given, let's label 2,000 grams. Well, grams is a measurement of mass, so M would be equal to 2,000 grams. 4.18 joules per grams degree Celsius. The joules per grams degree Celsius unit is associated with specific heat, and C is what we're using for specific heat. And delta T, the 20 degrees Celsius to 50 degrees Celsius change, that's a temperature degrees Celsius, so we're going to use delta T for that. And 20 to 50 is a 30 degree difference. And a lot of students ask me, well, which number do I subtract from the other number? And I really can't answer that question easily. It's just you have to look, because sometimes we have a negative temperature going up to a positive temperature, so you really can't subtract the two, and you really can't say, you know, take the bigger number and subtract the smaller number from it. You have to look at the change. Think about it as a number line, and you have to look at the change in temperature. Okay, so what are we solving for here? Well, we have M, C, and delta T. The question says how much heat, so Q is heat, so that's what we're solving for. So what is our plan? Well, our plan starts off with our formula for thermochemistry for heat problems, and that's Q is equal to mc delta T. Since we're already solving for Q, we don't have to rearrange. We just simply need to plug in now. So here I've set that up with the numbers plugged in, 2,000 grams. Here I plugged 2,000 grams in for M. Okay, and here I plugged in C, which is 4.18 joules per gram degree Celsius, and I actually rewrote the joules per grams degree Celsius, and I put it as a fraction. This is really a fraction, it's just written differently. And I put it over grams degrees Celsius because I'm going to show you how the units cancel out. And finally here, the delta T, 30 degrees Celsius. So on the units, remember that if a unit is above the line, then it's going to cancel the same thing that's below the line. So if we look at the grams, that grams on top of the line is going to cancel that grams that's below the line, as well as that Celsius cancels that Celsius. Okay, so we can see the unit that we're left with, the only unit we're left with is joules here. And if we look back at our notes, joules is the unit for heat. So this is one hint that this is set up correctly. So when we do the math is 2,000 times 4.18 times 30. Okay, it's straight multiplication. Then we're going to get 2.51 times 10 to the 5th, and our unit is joules there. Okay, so let's look at another problem. This is another sample problem. Again, we're going to go through the same GSP. Now, on this problem, we're going to have to rearrange our equation, Q is equal to MC delta T, because it's asking you to find the specific heat of aluminum. So it gives you grams, it gives you temperature, and then it gives you heat. So we're going to have to rearrange this algebraically to come up with an equation that C is equal to something. So here we have our original equation, Q is equal to MC delta T, and we want to get rid of M and delta T so we can isolate C on this side of the equation. And the way we do that is we divide by M and delta T. And if we do that to the left side, we have to do the same thing to the right side. Okay, so M cancels M, delta T cancels delta T here, and we're left with C. C is equal to Q over M delta T. So that's the equation, that's your plan. So I've helped you out there a little bit. So what I want you to do now is I want you to identify your givens, make sure they're in the correct units, plug that into your equation that we rearranged, and see if you get an answer. And the correct answer for this is 0.89 joules per grams degree Celsius. And make sure when you write down your numbers in your equation that you also write the units. That's very important.